Hello students, welcome to BioWise with Achal. Today we are going to study about water. Before going into the details of the chapter, I request you all, if you have not subscribed the channel, to subscribe the channel and share with your friends if you think they need the concept. Okay, so let us start with the chapter called water. It is an important chapter for standard 6 in the beginning and standard 8. Okay, in this chapter we'll be talking about the different properties of water, solubility, the factors on which the solubility depends, saturated solution, unsaturated solution, hardness in water, softness in water, that is hard water, soft water, water of crystallization, anhydrous, different types of salts. So yes, there are too many topics to be covered in this chapter, so be tuned till the last to understand the complete chapter on water. So let's begin with water. What is the molecular formula of water? H2O, right? Atomic mass, if you say the molecular weight, that is 2 for hydrogen, 1 plus 1, 2 and 16. So 18 AMU is the molecular weight of water molecule. Okay, water molecule has AMU. Now you know that 70% of the earth is made up of water. Now how is this water produced? When hydrogen gas is burnt in oxygen, you have the formation of H2O. We should balance it. Now this reaction only was studied, and that is how hydrogen has got its name. That is hydro, that is water, and gen means generating gas. So water generating gas, that is hydrogen. Okay, Henry Cavendish in the year 1781 discovered water is a compound made up of hydrogen and oxygen. Okay, so this is all about the introduction of water. Let me clear the board first. Yes, now if we need to talk about some important terms related to water. The first one is potable water. Okay, now you should understand the difference between potable water, seawater or saline water, or you can say distilled water. Distilled water is the purest form with no impurities. Okay, seawater has a higher content of salt, higher concentration of salt dissolved in it, and potable water is the water which we can drink. So this water we can actually drink, we can consume. We cannot consume these water. These water cannot be consumed. Okay, cannot be consumed. Okay. Now, what are the characteristics of potable water? It should be colorless, odorless, and it should have you can say a slight good taste, you can say, not completely tasteless. Tasteless is here. Okay, that is complete tasteless water is here. Okay, so property of water is colorless, odorless, tasteless. But here in case of potable water, it has got a very slight taste because of the presence of dissolved salts and certain gases. So therefore, potable water has a characteristic taste. Okay, yes, the taste should not be so much that you are not able to drink that water. Okay, now another thing that we talk about the potable water is that it should be free from any kind of microorganisms, free from disease causing organisms, disease causing organisms. Understood. So it should not be a source of diseases. Now you know that water, there are many waterborne diseases, right? Cholera, typhoid, dysentery. So when we consume dirty water, or when we consume water which is not from a very clean source, right, then we tend to get infections, and that leads to many diseases. So we should always have a clean and pure water for drinking purpose. We use RO at home. That the main purpose of RO is to have a clean water to drink. It does not mean that it does not have any dissolved salts or gases in it. The water which we drink has certain minerals in it. Mineral water we call it, right? So there are certain minerals present, certain dissolved salts present in the potable water. Is that clear? There are many resources of water, right? We have studied in 6th standard also that there is rainwater, pond water, sea water, river water. We can make it potable by certain steps that we can follow to purify the water. Now, seawater contains high amount of salt. So there is a process called reverse osmosis by which we can even take out drinking water from the seawater, but it's a costly process. Anyway, in your house also we have RO. RO is what? Reverse osmosis. It just helps in cleaning the water, reducing the amount of salts that are dissolved in water. Right. Then the simple method of purification of water is boil the water. So any kind of impurities or any kind of excess of salts can deposit, or even microorganisms, they can die. So we can drink the water by just boiling it and even using filters. Fine. This is all about the potable water. Now let us talk about the next topic. Next topic of water is that water has certain specific property. The first property of water is an universal solvent. Universal solvent. Now, universal solvent means it can dissolve almost, do not write everything, it can dissolve almost everything. That is why it is called an universal solvent. Almost everything means it can dissolve any material, whether it's very fast to dissolve or it will take little period of time, a long time to dissolve the substance in it. It will take certain time. There are few materials which cannot dissolve in water too, but most of the substances dissolve in water. That is why water is called an universal solvent. At the same time, there is one more property of water which is called anomalous expansion. Anomalous expansion of water. Now, what is anomalous expansion? When you talk about, like, you know that, right? Whenever you have any kind of water body and there is a cold temperature, that is temperature below 0 degree, we have ice formed only on the surface. The inside the water body, the fishes and all, they can easily stay in the liquid water. Now, why this happens? That is because of the anomalous expansion of water. In our previous chapters on matter, we have studied that solid changes to liquid, liquid changes to gas, right? Density of solid is maximum as compared to liquid and gas. That is, when the liquid freezes, it forms solid, then the density increases, correct? But in case of water, what happens? When the liquid water freezes till 4 degrees centigrade, density increases. After that, till it goes to the 0 degree, density decreases. Instead of contraction, expansion happens. This expansion is unique, is anomalous. That is why it is called an anomalous expansion of water, right? That means maximum density of water is at 4 degree centigrade. So if it forms ice, since the density of ice is lesser than water, it starts floating on water. And once ice is formed, you know that it acts as an insulator and does not allow the temperature to fall drastically inside the water body. So life exists on earth, right? Another important property of water is high specific heat capacity. High specific heat capacity. Now, specific heat capacity is what? The amount of heat required to raise the temperature of 1 gram of substance by 1 degree centigrade. Water requires a huge amount of energy for just 1 degree rise in temperature. Now, how this is helpful? This is helpful in the natural phenomenon of sea breeze and land breeze. Okay, the specific heat capacity of water helps in the movement of air. You know that during the summer season and all, when you go near the beach side, it is cooler as compared to the land. Why? Because water takes time to get heated up. So the air on the land is hot, it goes up, and the cool air from the sea comes and takes the place. That is sea breeze. At night, water takes long time to cool down. So the air above that water is warmer. It goes up, and from the land, the breeze goes to the sea. This is called land breeze. So water plays a very important role in all this in geographical, biological phenomenon, you can say. Okay. So and even you have seen that when your parents, when your mother gives you milk to drink and it's very hot, she keeps it in a bowl of water. Why? Because milk will get cooled faster because water absorbs the heat. For every 1 degree rise of temperature of water, it will absorb more heat from the milk. That is why milk, or for any coolant, we use water. Is that clear? Understood? Now let us move to the next topic about solubility. For knowing about solubility, you should know what is a solute, what is a solvent, and what is a solution. Okay. Now, solute is the substance which is added to solvent to make a solution. For example, if I take salt, add it to water, water is a solvent, and it gives you the salt solution. Okay. So, depending upon the concentration of the salt in the solvent, you have three types of solutions. One is called the saturated solution, one is called the unsaturated solution, and the other one is called the supersaturated solution. Yes, now when I say saturated solution, saturated means what? You're satisfied. So the solution is satisfied. No more solute can be added to the solution at a fixed temperature. Now, before understanding this, we should know that what are the factors which affect solubility. So, the most important factor which affects solubility is temperature. When you increase the temperature, the solubility of a solid increases, right? But that will be little different in case of gases. We'll come to it after this. But understand now, when we talk about the solubility of a solid in a solvent, as the temperature increases, the solubility also increases. Fine. So when we talk about a saturated solution, suppose I have taken a solution at, say this is 100 gram of water at 25 degrees centigrade. Okay, fixed temperature. I have added 1 tablespoon of sugar and it dissolves completely. So I'll keep on adding sugar till the time it gets dissolved. Before the settling starts. So when the settling starts, just before that moment, it is considered to be a saturated solution. Now tell me, if I increase the temperature, what will happen? The saturation will get over. It will not be saturated anymore, because once you increase the temperature, the molecules of water tend to move apart, creating more space for the solute to get dissolved in it. So what happens? Solubility increases. So the saturated solution becomes unsaturated now. Okay. Now what will happen if I decrease the temperature? So at a lower temperature, the amount of sugar that was already dissolved in it will be maximum. Okay. More than the required amount. That is what it is, supersaturated solution. Is that clear? Understood? Put a thumbs up in the comment section if you're understanding what I am teaching you. Yes? Yes. So this is all about the saturation, and solubility factors we'll talk about. But have you understood saturated, unsaturated, and supersaturated solutions? Supersaturated solutions, like rasgulla, you eat gulab jamun, the pak that is being made, that is a super saturated solution. You leave it, you will cool it, you start getting crystals, right? So that is super saturated solution. So how can you define solubility? Solubility can be defined as the amount of solute that is added to water. How much water? 100 grams of water. The amount of solute added to 100 gram of water to make a saturated solution at a fixed temperature. Please mention fixed temperature, because if you don't mention temperature, then the saturation will be of no use, because as you increase the temperature, the solubility will increase. When you decrease the temperature, solubility will decrease. So how will you talk about saturation, unsaturation and supersaturated solution? You have to mention the fixed temperature. Is that clear? This is about solubility. Now for solubility, there are certain conditions required. The conditions. In this, first condition is the nature of the solvent. Nature of the solvent and even solute. For example, if I take salt and dissolve it in oil, then it will not be soluble, right? But if I take water as a solvent, then it will dissolve. So we have to find out that the correct solvent and the solute is taken. Okay. Next is temperature. Temperature also plays a very significant role in determining the solubility of a substance. Then you talk about the particle size. Particle size. Now, if I have got sugar powder, or you can have sugar cubes, or you can have those mystery, we get it, no, that complete rock of sugar, which one will dissolve faster? The powder will dissolve faster, correct? Why? Because lesser the size, more surface area, more interaction with the solvent, so easily it gets dissolved in the solvent, correct? And also the process of making the solution. Now suppose I have taken a glass of water, I have added sugar to it, but I am not mixing it, I am I am just leaving it like that. And I take a glass of water, I add sugar and then I stir it with the spoon. So which one will dissolve faster? Where the steering, we are aiding the process of getting dissolved, right? So the process is also very important for the condition for solubility. Now there are two ways. First is you can dissolve a solid in a solvent, like salt in water. Example, salt in water, or you can just have gases dissolved in water. Gases in water. Now you tell me, with temperature what will happen? Temperature and let us talk about temperature. Now in this case where the solute is a solid, when you increase the temperature, solubility increases. How will you remember this? When you just increase the temperature of water, you can add more and more salt to it, right? Now but this, when in case of gases, it is opposite. When you increase the temperature, solubility of the gases decreases. Solubility of the gas decreases. Okay. Now a very good example, take water, boil it. Okay. All the dissolved gases will leave. Then freeze it and make an ice. When you make ice, you'll find that ice is crystal clear because there is no dissolved gases in it. But when you take tap water and make ice, it is white in color, right? You can try this at home. So why? What is the difference between this two ice? In one case, dissolved gases have all escaped. Have you ever seen water boiling? You find small bubbles coming out. What are those? Those are dissolved gases. Understood? So when you increase the temperature, solubility of the gases decreases. But when you increase the temperature, solubility of the solute, solid solute, increases. This is very important to keep in mind. Clear? Let's now this there is an important application that I think you can answer now. Like you have heard about thermal pollution. That is, we add hot water to the lake and the pond and the water close by, and it leads to death of the fishes present in the pond. What is the reason? Now, when you add hot water to any kind of water bodies, the dissolved gases escape, because when you increase the temperature of the water, the solubility of the gases in that water body decreases. So what will happen? The fishes, they will die, right? That is what thermal pollution is really problematic to the marine life, or you can say the aquatic life. Fine. The basic reason is increase in temperature decreases the solubility of the gases. Fine. So this is one application based question that can be asked from this topic. Fine. So let us move ahead. So there are different types of solutions, right? Based on the substance which get dissolved in it, you can have three types of solutions. So when I talk about solutions, solution is what? Solute plus solvent. But it's not important that the solute will completely dissolve in the solvent. So you have three types. The first one is a true solution. Okay. The first one is true solution. Okay. Next one is colloid, intermediate, and the last one is suspension. Okay, suspension. Now, generally, true solution is a clear solution, clear, transparent solution. Colloids are opaque, you can say turbid, and these are totally, you can see different materials either settled down or it is floating on the top. So this, it has suspended impurities in it, suspended or settled particles are there, okay, in this case. Now when you talk about the size, the solute size is basically less than 1 nanometer, okay. For colloid it is 1 to 100 nanometer range, and for suspension it is greater than, it is, the particle, this particle size is greater than 100 nanometer. You know what is nanometer, right? 10 raised to minus 9 meters. So this is the size. In case of true solutions, they can easily pass through filter paper. Okay. It can also pass through filter paper. Right? Filter paper positive, you can say pass through. But this cannot pass through the filter paper. If you take membrane, like in case of osmosis, semi-permeable membrane, so your true solution can easily pass through it, your colloidal solution cannot pass through it, and suspension can never ever pass through it. Understood? Then there are certain effects which are shown by the colloidal particle. One is the Brownian motion, that is the zigzag random movement of the particles in the, in which it is suspended, and Tyndall effect, that is scattering of the light. The scattering of the light and Brownian motion are the specific property of the colloids. Actually, colloid is a homogeneous appearing heterogeneous mixture, in simple terms. It looks homogeneous like your blood. When you touch blood, it's so homogeneous in your field, right? Milk, it's so homogeneous when you see it. But actually, when you see blood, it is made up of so many cells, plasma. So in plasma, there are so many cells suspended in it. Milk also, the milk proteins are suspended in water, but they are so small that it appears homogeneous to our naked eye. But when you see it under a microscope, you'll see the difference. When you see a true solution under microscope, you cannot make anything. You cannot see the solute. You cannot see the particles present. But when you observe the colloids, you can see the particles present. But they are very small. Okay, that is the difference between a true solution, a colloid, and a suspension. True solution example: sugar solution, salt solution, any kind of mixtures you make in your chemistry lab which looks transparent, addition of any salt to water and it dissolves completely gives you a true solution. Colloid example is milk, blood. Suspension, you can have in chalk powder in water, uh, mud in water, that is all suspension. Okay, before starting with the next topic, I have a question. How can you make a saturated solution an unsaturated solution. That is, how can you make a saturated solution, to unsaturated solution, unsaturated solution. Yes, saturated solution means it cannot dissolve any more solute. Unsaturated solution means it needs little bit. So what I'll do, I'll heat it. So by increasing the temperature, I'm actually making a unsaturated solution into a saturated solution, and by another way, by adding more of solvent. So if I add more of solvent, obviously the ability to take more of solute will increase. Yes, clear? Now there are certain salts given here in the picture. You can identify these salts, and what do you think these salts are, and why they have so beautiful colors, and why they look so pretty? Is there something related to chemistry or something related to water? So we'll study crystals. What are crystals? Crystals are basically a structure where you have specific geometric shape, then they have sharp edges, right? They have sharp edges, they have distinct structures, distinct, you can write distinct shapes or structures, both are same. Okay, so what are crystals? In chemistry, we have many compounds which are in the form of crystals, and you can actually make crystals by the process of crystallization. Crystallization. In the chapter, I think element, compound and mixture, we studied about crystallization and fractional crystallization. Remember, potassium nitrite and potassium nitrate can be separated by fractional crystallization because their solubility is different. Crystallization is a process by which crystals are made from supersaturated solutions. When, or you can say, if you make a very hot supersaturated solution and you cool it, generally the crystal separates out. This is a process of crystallization, right? If you have multiple compounds which are dissolved in the supersaturated solution, then you have fractional crystallization. Clear? So crystallization is a process of making crystals from the supersaturated solutions of those salts in specific solvents. Fine. Now there are certain salts which has, like for example, blue vitriol. Blue vitriol. Now blue vitriol, the formula is copper sulfate and 5H2O. What is this 5H2O? This is not a molecule of water which is chemically combined. That is, it does not form a compound as such. This molecule of water remains with this salt with a weak force of attraction, and this is a fixed molecule of water which is called water of crystallization. Water of crystallization. So any kind of crystal salts, if you have seen, it has got certain amount of water of crystallization. So let us take a very quick review of all few compounds which has water of crystallization attached to it. Now here are certain names that we are going to study about. These are certain molecules, certain compounds which have water of crystallization, like washing soda. Washing soda is what? Sodium carbonate, right? Sodium carbonate and decahydrate. Calcium sulfate dihydrate. Blue vitriol is copper sulfate pentahydrate. Green vitriol is iron sulfate, and that is 7 molecules of water of crystallization, heptahydrate. Okay. Globose salt is sodium sulfate decahydrate, मतलब 10 molecules of water of crystallization. Lime salt petre, it is calcium nitrate, 4 molecules of water of crystallization. Epsom salt is magnesium sulfate with 7 molecules of water of crystallization. So these are certain examples of the salts crystals with water of crystallization. You can see here the different molecules. These numbers are fixed, children. You cannot change these numbers, okay? These numbers are all fixed. The water of crystallization is fixed for the molecules. So if you have to define the water of crystallization, the water of crystallization is the fixed amount of water molecule associated with the salt to provide it or to give it a crystalline structure. When they tend to lose these water of crystallization, they turn into the amorphous form of their salt. So if suppose copper sulfate is heated, so it will lose the water of crystallization and will form amorphous white copper sulfate. It is blue crystalline copper sulfate, blue vitriol. So once it is heated, it will lose the water of crystallization and will form amorphous white copper sulfate. Similarly, you have these washing soda. When it is left in the atmosphere, it loses the water of crystallization and forms amorphous sodium carbonate. Right? This understood? You can take a screenshot if you want. Water of crystallization. Now, what do you think how these crystals are made? So, whenever a hot saturated solution is cooled very slowly, these molecules attain a very beautiful geometric shape and forms the crystals. So, these crystalline salts are formed upon slow, cooling of a saturated solution. Okay, and when they tend to lose this water of crystallization, they form the amorphous salts. So depending upon these types and varieties of salts, we have certain technical terms related to salt. The first one is the crystalline salt. Now crystalline salts are the salts which have water of crystallization. When these crystalline salts loses their water of crystallization, they form amorphous salts. Okay, now these crystalline salts are also called hydrated salts because they have water molecule attached to it. So they are also called hydrated salt. Is that clear? Then you have the amorphous salt. Now for amorphous salt, hydrated salt, the examples we have already seen. Amorphous salts, example KNO3, sodium nitrite, lead chloride, etc. So many are the amorphous salts. Okay. Next we talk about the efflorescent salt. Substances or salts. Now when you talk about the efflorescent substances, now as we have already discussed that washing soda, okay, the real formula you can say washing soda is sodium carbonate decahydrate. Okay, and it loses around 9 molecules of water when it is left like that to form sodium carbonate monohydrate washing soda. These are both washing soda, but this is a crystalline form of washing soda, and finally it forms amorphous powdery substance that is called the amorphous form. So this loss of water, water of crystallization, this loss of water of crystallization when just left in the atmosphere like that is called the efflorescent substances. So all those hydrated salts which has the capacity to lose the water of crystallization when exposed to the atmosphere, it is called efflorescent substances or salts. Is that clear? Next we talk about the deliquescent. Deliquescent salts or substances. Deliquescent substances. Now they efflorescent means water exits. Efflorescent means water exits. Deliquescent means it becomes dilute. Deliquescent, it becomes dilute. So what happens? We have salt like calcium chloride. When you keep it in water for some period of time, calcium chloride, when you expose it to the atmosphere, it will absorb the moisture from the atmosphere and form a solution. So, have you ever been to some dhabas and all where you find that the the salt becomes very sticky, or sometimes even water is present? So, what is wrong with that salt? These salts have got impurities. What is the formula of salt? NaCl. But NaCl itself is not deliquescent. It contains impurities like calcium chloride, magnesium chloride, which when exposed to the atmosphere absorbs moisture and forms a solution, a saturated solution. So they become moist and they become watery, right? So that is deliquescent nature of the substances. So they have impurities of magnesium chloride and calcium chloride, and these are deliquescent in nature. They absorb moisture to become saturated solutions, liquids. Okay, so how will you understand, how will you remember? Efflorescent means water exits, water of crystallization exits, and deliquescent means dilute, the solution becomes dilute, water gets added to it. Fine. The next one is hygroscopic. Hygroscopic. Now hygroscopic is, they absorb water but they do not form solutions. Okay, they do not form solutions, they just remain as it is, they remain solid, but they tend to absorb moisture. So hygroscopic substances, like you have calcium oxide, it remains solid. Even after absorbing moisture, it remains solid. Now one more example here is ferric chloride, right? Ferric chloride, even in laboratories, when they are kept open, no, they form a solution. So in labs we find this. Now there are few examples, children, which you will get confused. Like calcium chloride is a very good desiccating. Desiccating agent means it absorbs moisture, right? And so it is used for drying substances and all. Desiccating agent. Then you have something called drying agent. Drying agent means like concentrated H2SO4. Concentrated H2SO4, P2O5, phosphorus pentaoxide. When you transfer any or you pass any kind of gases with which has impurities, moisture as impurities, these substances can absorb water and remove this moisture from the gases. So we collect dry gases basically in the formation of, I think, sulfur dioxide. We use concentrated sulfuric acid to remove excess of moisture. Sulfur dioxide gas, once it is produced by roasting of some iron ores, then it is passed through concentrated sulfuric acid, so that any moisture, if it is present, is absorbed by concentrated sulfuric acid. Similarly, use phosphorus pentaoxide also. So there is a dehydrating agent. Dehydrating matlab chemical reaction. Dehydrating means water is removed from a substance. Earlier it had, like for example, if you take glucose, have glucose C6H12O6. When it is treated with concentrated H2SO4, you know that concentrated H2SO4 is a very good dehydrating agent. It removes water. So you have the formation of carbon and you have the formation of water. 6 molecules of water and 6 carbon is formed. So in this case, the water is removed from the compound itself. So it is a dehydrating agent. It's a chemical reaction. Dehydrating agents, matlab they remove water completely from the compound. Is that clear? So we have understood what are crystalline substances. Crystalline substances have water of crystallization attached to it. So it gives them a geometric shape, a crystalline structure, a beautiful color. Okay. Then amorphous, when this crystalline substances loses the fixed amount of water of crystallization molecule attached to it, it forms a amorphous substance. Then you have efflorescent substances. Efflorescent means exit of the water of crystallization. So the crystalline substance, when exposed to the atmosphere, turns into an amorphous substance without you doing anything. The molecule itself is losing the water of crystallization, right? Then you have deliquescent. Deliquescent, dilute. So deliquescent substances are those substances which absorb moisture from the atmosphere and it becomes a solution, right? Then you have got the hygroscopic substances. Hygroscopic substances are those which absorb moisture but they do not change their state. Like silica gel is also there, no? Sometimes when we purchase water bottles, purses, leather substances, we get a small silica pouches. that tends to absorb moisture. Okay, then you have desiccating substances like calcium chloride. It absorbs moisture present in the surrounding. So the substance which you keep remains dry, it does not get spoiled, right? Then you have got dehydrating agents. Dehydrating agents means these are taking out water from the compound itself, right? So this is dehydrating substances. I hope I made the things clear. Yes. Next we'll be talking about the reactions of water. So when we talk about the reactions, that is chemical properties of water. So next we talk about the chemical properties of water. So before talking about the properties of water, I hope you remember the metal reactivity series, right? This is the metal reactivity series K, Na, Ca, Mg, Al, Zn, Fe, Pb, H. H is a non-metal, still it behaves like some metals and non-metals, so let it be. Uh, right, so then you have copper, then after copper you have mercury, silver, gold and platinum. These do not react with water. Okay, that is why these are all costly metals for the jewelry making, right? Now when you talk about actually below hydrogen, there is no reaction with water, because hydrogen, the metals which are below hydrogen cannot displace hydrogen from water. Now here these three are the reactive elements, they react very vigorously, and these are the less reactive metals. For them the reaction will take place if the water is present in the form of steam, and for some metals it has to be red hot iron when it reacts with water. So when like can write the reactions. When K reacts with water, you have the formation of KOH, remember this, and hydrogen gas is released. Balance the reaction. Right. Then similarly, when you talk about sodium, sodium also reacts in the similar way, reacts very vigorously with even cold water. They react with cold water to form respective bases, alkali and hydrogen gas. Calcium reacts with water to form calcium hydroxide and hydrogen gas. Okay, so this is this balanced? Fine. Reactive metals, when they react with water, they form bases, right? But when these less reactive metals react with water, they form oxides. You have to write a balanced reaction. Zinc reacts with water to form zinc oxide plus H2. Fe reacts with water to form Fe3O4 triferric tetraoxide plus hydrogen. Okay. Lead also reacts with water very slowly, so we are not writing the reaction. Below hydrogen, there is no reaction with water. This is the reaction where metal reacts with water, right? So, reaction of water with metals. Next, we talk about the reaction with certain oxides. Before talking about the reaction of water with the oxides, you know that oxides can be of two types, right? One is a metallic oxide and one is a non-metallic oxide. So when you talk about the metallic oxides are generally basic in nature, and non-metallic oxides are generally acidic in nature. Remember children, I am not talking about the neutral oxides and amphoteric oxides right now. Right. So when you talk about the metallic oxides like Na2O, MgO, calcium oxide. You can have zinc oxide. So when these reacts with water, you have the formation of bases. NaOH, MgOH, right? Then you have calcium hydroxide, and similarly you have zinc hydroxide or copper hydroxide. Whichever metal you use, you have the formation of that hydroxide. Correct? So this is the metallic oxide. So these are all bases. So metallic oxides basically gives you the basic oxides. Okay, they do have amphoteric oxides. I hope you remember ZAP, that is zinc, aluminium and lead. The oxide of these metals are amphoteric. Amphoteric means they react with both acids and bases to form salt, right? So this is, we are not talking about right now. We are just a reaction of water with the metallic oxides. Similarly, when you talk about the non-metallic oxides like sulfur dioxide, when sulfur dioxide reacts with water, you have the formation of sulfurous acid, H2SO3. When sulfur trioxide reacts with water, you have the formation of sulfuric acid, H2SO4. You have the formation of carbonic acid, right? So you have the formation of carbonic acid, H2CO3. So whenever a non-metallic oxide reacts with water, you have the formation of acid. This is the basis for the acid rain also, right? NO2, nitrogen dioxide, also reacts with water to form nitrous acid and nitric acid both. Similarly, these are all acidic oxides. Fine. There are few neutral oxides also like carbon monoxide, water, nitrogen monoxide. These are all neutral oxides. That is non-metallic oxides, but they are neutral. But here they are acidic because they form acid. This is acidic oxides and basic oxides. Is this clear? Any doubt? Put it in the comment section. Next, we talk about the hardness of water. Hardness of water. Children, here we are not talking about the strength. Like once I had a child, I don't know, hard water means ice, soft water means steam. It's not like that. Hard water and soft water depends upon its ability to give lather with soap. So if the water gives good lather with soap, good lather with soap, it is called soft water. Soft water is good for the cloth, good for bathing, washing your face, right? Similarly, which does not give good lather, matlab no lather, or it forms scum, no lather, forms scum, sticky scum, then it is hard water. Okay, and why we have hard water? This is because of the presence of the salts of calcium and magnesium salts, okay, which reacts with soap and forms scum, which does not help in cleaning clothes, right? So that is why if it is hard water, there is lots of wastage of soap and all. So there are many ways how by which we can remove this hardness. So let us talk about that. Soft water, I hope you have understood, which gives you good lather with soap, that is called soft water. We'll focus on hard water. Okay, so when you talk about hard water, hardness can be of two types. Hardness can be of two types. One is temporary hardness, hardness, and the other one is permanent hardness, of water. Now, temporary hardness of water can be actually removed by just boiling, okay, and permanent hardness, you need washing soda to remove the permanent hardness. Clear? What is clear? Now, what is the cause of temporary hardness? It is the bicarbonates of calcium and magnesium. And what causes the permanent hardness? It is the chlorides and sulfates. Chlorides and sulfates, okay, of calcium and magnesium. Is that clear? So if chlorides and sulfates of these chlorides and sulfates are soluble in water. So when they are soluble in water and when you add soap to it, they react with soap and they form scum. If by any means you can precipitate these salts out of the water, you can remove the hardness of water. Clear? So let us proceed with the process how we can remove hardness of water. So let us talk about temporary hardness first. So as I told you, what is responsible for temporary hardness is the bicarbonate salt of calcium and magnesium. So calcium bicarbonate. Now this bicarbonate, when it is present in the water, it adds up to the hardness of water. But when you boil it, it forms, calcium valency is 2. So it forms calcium carbonate and this carbonate settles down with water and carbon dioxide. So now this calcium carbonate, if it settles down, you know that calcium carbonate is insoluble in water, it settles down, so the hardness is removed. Now the water is not having any dissolved impurities which will react with soap to form scum. Similarly, when you talk about magnesium bicarbonate and you boil it, so you have the formation of magnesium carbonate plus water and carbon dioxide. Now, you must have seen, if you have any kind of hard water supply in your house, you get some kind of deposits on the bucket and the utensils which you use, right? So hard water is very problematic. Even for washing clothes, washing machines, they form a kind of deposit on the utensils and the buckets, right? So that becomes a problem. So now how you can remove it? Either boil the water so that the carbonate settle down and you can just filter it out and use the water again. This is how the temporary hardness of water is removed. The cause of temporary hardness is bicarbonates, which can be changed into carbonates by simply boiling it, right? Next is the permanent hardness. When you talk about the permanent hardness, what is the cause of permanent hardness? Permanent hardness is caused by the chlorides and the sulfates of calcium and magnesium. Always remember that whatever we are using for the purpose of removal of hardness of permanent hardness, that is, we use sodium carbonate, that is your washing soda, it can remove the temporary hardness too. Okay, we'll see the reaction little later, but like for example here, calcium chloride. Calcium chloride is a substance which dissolves in water and makes it hard. So when you react it with sodium carbonate, right? Sodium carbonate, it will form calcium carbonate. So the calcium salt gets deposited plus 2 NaCl. NaCl do not contribute to the what? To the hardness. Correct. So NaCl is formed and the water is now ready to use for washing clothes and utensils. Similarly, magnesium chloride, when reacts with the washing soda, you have the formation of magnesium carbonate and 2 molecules of NaCl. Similarly, when you have the formation of calcium sulfate, it reacts with sodium carbonate. You have the formation of sodium sulfate, which is not dissolved, plus calcium carbonate which settles down. These are all soluble substances which do not participate in the hardness of water, and the substance which was creating an issue, they have precipitated down. Similarly, you have magnesium sulfate. When it reacts with sodium carbonate, it forms Na2SO4, which is not a problem, but you have the deposition of magnesium carbonate, right? So this are all related to permanent hardness, correct? Now temporary hardness, the cause was what? Calcium bicarbonate, right? So when this bicarbonate also reacts with the washing soda, you have the formation of sodium bicarbonate, which is again soluble in water, and you have the formation of calcium carbonate, hence the hardness is removed. So I hope these reactions has made your life little easy to understand what is hardness of water and how it can be removed. I hope you have understood the chapter. For any query, put it in the comment section. I'll see to it that your query is taken by me, or if you need any video on any topic, please let me know. This video was made on a request of one of the students, so I have made the video on water. Now if you have any problem, put it in the